Weather. You have definitely experienced some form of it. If you live on Earth, that is. Sure, you may have been in a rain shower once, or twice even, where, well, it rains water. But have you ever been in a rain shower where, instead of raining water, it rains frogs? Better yet, have you ever walked outside on a nice day where the sky is blue, there isn't a single cloud in the sky, and suddenly you're hit by a bolt of lightning? Chances are, probably not, because you are currently watching the weather phenomenon Iceberg, Part 1, where I will rank weather and meteorological phenomenon by most commonly known to least known. Yeah, this script is pretty long, so just sit back, relax, as I take you on a deep dive into the weather phenomenon Iceberg. Have you ever looked at the sky and wondered, why are you blue? It is a common misconception that the reason our sky is blue is because it reflects the color of the oceans and the seas, when in fact, the sky is blue due to the atmosphere scattering the light that comes from the sun. Of course, there's a lot more science that goes into this, and I'm definitely not going to get into it here. So remember this, light goes through air, it bounces around, it turned blue. Those big white fluffy things you see in the sky, yeah, those aren't actually made of cotton candy. Wait, can't believe I just found this out. Wait, is this the right script? What is? Clouds are actually made of tiny particles of super cold water vapor and ice. When these tiny droplets of ice and water vapor become too heavy, something happens, which you probably know what it is. Water falling from the sky. What more can be said about rain? Rain happens when the tiny water and ice droplets that make up a cloud are too heavy to float in the air, and because of gravity, they fall down. As the frozen droplets reach the surface, they begin to melt into liquid water, thus raindrops. But wait, they aren't really shaped like this though. Raindrops are actually shaped like, well, they aren't exactly one shape. A raindrop will vary based on the size of the drop itself. A raindrop with a diameter of 1 millimeter will almost always be spherical. A raindrop with a diameter of 2 to 3 millimeters will have the shape of a hamburger bun, but at a diameter of 4 millimeters, raindrops don't exactly resemble drops anymore. Instead, the drop will look more like a parachute with an annular ring around it. Eventually, as the raindrop continues to fall, the weird parachute shape will just burst into little spherical drops again. Wind is the movement of air caused by uneven heating of the earth by the sun. As the surface of the earth is heated, there is an area of low pressure left behind as the air rises. Cold air will see this area of low pressure and be like, hey look, we have to go fill the empty void. So cold, dense air will rush in to fill the void. So basically, just think of wind as being caused by massive convection currents. Rainbows are the colorful arches of light you see during or after a rainstorm. These colorful arches are caused by the scattering of sunlight from raindrops. Like I talked about previously, most raindrops are actually spherical, which allows light to refract in there in just the right way. And no, there is not a pot of gold at the end of one of these. Remember how rain forms when the frozen droplets of water just melt as they come down? What if, as the rain comes down, the temperature remains below freezing? You get snowflakes. But why is snow shaped like this? It's because as snowflakes fall towards the ground, ice builds onto the primary crystal, forming new crystal arms. Small differences in atmospheric conditions can cause snowflakes to form into 7 different types of shapes. Snowflakes can be star-shaped, needle-shaped, dendrite-shaped, which is the shape that is most commonly associated with a snowflake, plate-shaped, column-shaped, capped column-shaped, and irregularly shaped. Freezing rain is basically just snowfall that encounters a layer of warm air as it falls towards the surface. The snow will melt into rain, but when the rain comes into contact with the surface, it will freeze again. Freezing rain is considered to be the most dangerous type of winter weather, as a heavy amount of freezing rain can cause damage to trees and power lines. Sleet is snow that melts as it falls through a shallow layer of warm air. Unlike freezing rain, the raindrops will refreeze in the air before making contact with the surface. This will result in frozen raindrops that will bounce on impact with the ground. Alright, so now we are at layer 2, which is where things are gonna get kind of scary. So yeah, this early in the iceberg already. Lightning is a powerful discharge of electricity. So powerful, in fact, that a typical lightning strike releases about 300 million volts of electricity in a fraction of a second. For comparison, a typical wall outlet in North America outputs a constant 120 volts. So that means a lightning bolt is around 2.5 million times more powerful than the wall outlet you are using to charge your phone right now. And yes, I know what some of you are thinking, which, you know, you probably should not go outside and try to charge your phone with a lightning strike, so yeah, don't do that. How does lightning even happen? Well, it definitely ain't Zeus or Thor, but ice crystals. Ice crystals rub against each other in the turbulent upper level winds of a storm. The constant rubbing of ice crystals gives the cloud a polar charge, with the bottom of the storm cloud being negatively charged and the top of the storm cloud being positively charged. The lightning we typically see touch the ground occurs when the negatively charged cloud base attracts positive charges on the ground. The positively charged electrons will then move up onto the tallest objects, such as trees or a human, if you are unlucky. Then, what's called the step leader will come down from the cloud base seeking a positively charged upward streamer. When they eventually meet, a channel of very, very hot plasma will form. This channel of hot plasma can heat the air to a nice, warm and toasty 50,000 degrees Fahrenheit. The extremely high temperature of the lightning bolt is what actually causes thunder, as the air around the bolt is heated so quickly and to such a high temperature that a shockwave is created. Now imagine this happening several times a second during a rainstorm, almost like a storm of thunder. A thunderstorm is basically a rainstorm that produces lightning. In addition to lightning, thunderstorms can also produce extremely heavy rainfall, strong winds, hail, and tornadoes, which I will go into detail about these in a little bit. Thunderstorms can form as a singular cell, a cluster, or a squall line, which can stretch a couple hundred miles. Thunderstorms can even begin rotating, and these are classified as supercell thunderstorms. More on those later as well. Hail is precipitation that forms when updrafts in a thunderstorm carry raindrops high into the atmosphere, where it then freezes and falls back down to the surface. The stronger and more sustained the updraft of a thunderstorm, the larger the hailstone size. Small hailstones typically need an updraft of about 24 to 40 miles per hour, while the absolute chunker hailstones need a 60 plus mile per hour updraft. Hail can damage anything from cars to aircraft and even kill livestock and people if the hailstones are large enough. A tornado is a violently rotating column of air that extends from the base of a thunderstorm to the ground. Since wind is invisible, tornadoes only become visible when they develop a condensation funnel made up of water droplets, dust, and debris. Tornadoes are considered by the National Oceanic and Atmospheric Administration to be some of the most violent weather events to occur on Earth. And yeah, I am inclined to believe them. Tornado strength is measured with the EF or Enhanced Fujita scale. The EF scale uses damage indicators to estimate the wind speeds and overall strength of a tornado. Tornado strength using the EF scale can range from EF0, which is minimal damage with winds ranging from 40 to 72 miles per hour, to EF5, which is complete and utter devastation, with wind speeds ranging from 260 miles per hour to an insane 300 plus miles per hour. Which, by the way, those are some of the fastest wind speeds to ever occur on Earth.
Folks, please, we plead with you. You absolutely have got to get down. Go get safe. Oh my gosh.
89, South 89.
Folks, we plead with you, just go to your safe spot if you possibly can. That's an F. Look at the horizontal vortex.
But where do these long tubes of death even come from? Well, the answer is pretty simple. We don't actually know. But we do know what conditions will be ripe for one of these tubes of death to form. Think of it like ingredients for a really, really scary cake. There are two very important things that are needed for the formation of a tornado. You need more moist air near the ground and cold, dry air up high. These two ingredients are abundant in the plains of the United States, with the Rocky Mountains providing the cold, dry air and the Gulf of Mexico providing the warm, moist air. You also need a change in wind speed or direction with height, also known as wind shear. The unstable air mass will promote the formation of strong updrafts, while wind shear will increase the strength of the updraft and promote rotation. When the updraft of a thunderstorm begins rotating, it is called a mesocyclone. When rotation is detected in a storm by a Doppler radar, a tornado warning will be issued. So, if you happen to be in this lovely red box on the map, get as far away from the outside as possible, because there might be a tornado nearby, who knows. The formation of the funnel itself is not precisely known, but recent theories suggest that tornado development is related to the temperature differences across the edge of the downdraft air wrapping around them. Yeah, trust me, the science behind tornado formation gets really, really complex, and I will definitely not get into the exact science behind the formation of one of these tubes of spinning death, as this video will probably be 500 hours long, who knows. But as technology advances, we find out more and more interesting things about tornadoes, the environments they form in, and what leads to the formation of the most destructive ones. Flooding is an overflow of water onto land that is normally dry. Flooding can be caused by many different things, but mainly heavy rainfall and storm surge. But flooding can also occur when snow melts too quickly, a river overflows, or when a dam or levee breaks. Flooding waters can be as much as a small nuisance on the front doorstep to turning your whole city into a communal swimming pool. Okay, but seriously though, please do not try to swim in flooded waters. It is very dangerous. According to the National Oceanic and Atmospheric Administration, flooding is the most common and most widespread of all weather-related natural disasters. And in the United States, it kills more people than tornadoes, hurricanes, and lightning. The most dangerous type of flooding is known as flash flooding. And as the name suggests, flooding happens over a short period of time. Flash flooding can occur within minutes of rainfall, which severely limits the available time to warn the public. Flash flooding is especially dangerous to drivers. You've probably heard the phrase, "turn around, don't drown," when a major flood event is occurring. The phrase is basically telling you, don't drive into flooded waters, just go the opposite way. The whole reason this phrase was coined in the first place is because over 50% of all flood-related deaths occur in vehicles. A dust storm is a wall of dust and debris that is blown into an area by strong winds. Dust storms can be several miles long and several thousand feet high. Dust storms mainly occur in places that are geographically flat and have very few plants and trees. Because of the lack of plants and trees, wind is able to build up momentum and get stronger, which drives a lot of dust into the atmosphere. Dust storms on Earth mainly occur in the Middle East and Northern Africa. But dust storms can also happen anywhere in the United States, but mainly in the Southwest during springtime. On any given day, dust storms kick up a lot of dust. It is estimated that an average 44 billion pounds or 2.2 million tons of dust is floating around in the Earth's atmosphere. Although dust storms usually last for a short amount of time, they can still cause problems such as low visibility and difficulty breathing outdoors. Dust devils are small, dust-filled vortices. They look like miniature tornadoes, which they kind of are, but they form in much different conditions and environments. These devils of dust form in pockets of hot air near the surface, rise quickly through the cooler air above it, forming an updraft. If conditions are right, this updraft may begin rotating. Dust devils typically last a few minutes and are usually 10 to 300 feet wide and 500 to 1,000 feet tall. But in the treacherous deserts of Arizona, dust devils are known to be several thousand feet tall and lasting up to an hour or even more. Now, these are the dust devils you gotta watch out for, as their winds can reach 60 plus miles per hour. A tornado of this strength would be classified as an EF0. In this case, please do not try to run through one of these, or you'll end up like this guy. Hurricanes are massive low-pressure systems with organized thunderstorm activity that form over tropical or subtropical waters. These ginormous storm systems form from a group of thunderstorms, also known as a tropical wave. In order for a tropical wave to form into a tropical cyclone, some criteria must be met first, which are warm ocean waters, unstable atmosphere, moist air near the mid-levels of the atmosphere, must be 200 miles from the equator due to the Coriolis effect, and low vertical wind shear. If a tropical wave is shown to have winds of 39 to 73 miles per hour, it is classified as a tropical storm and given a name. Each storm throughout the year will be given a name in alphabetical order, but if the alphabet somehow runs out, then Greek letters are used instead of names. As a tropical storm remains over warm water, it will continue to grow, and if the winds reach above 74 miles per hour, then it is officially classified as a Category 1 hurricane. Warm water is the key here to the strength of a hurricane. As a hurricane remains over warm waters, it will continue to grow and strengthen, with the strongest of these storms being classified as a Category 5, which is the highest classification in the scale used to measure hurricanes, which goes from 1 to 5. Category 5 hurricanes are the stuff of nightmares. The winds in one of these storms have to be at least 157 miles per hour to even be classified as a Category 5. But in 2015, during Hurricane Patricia's peak intensity, 1 minute sustained winds reached as high as 215 miles per hour, which can completely level any house no matter what it is made of. On top of that, these absolutely terrifying storms can produce storm surges as high as 20 feet. But you should not worry, because Category 5 hurricanes are extraordinarily rare. Since 1924, only 37 hurricanes in the Atlantic Basin have had the honor of being classified as Category 5 storms. Of these 37 hurricanes, only 4 have made landfall in the United States, with Hurricane Michael being the most recent, having made landfall in 2018 in Florida. Dairy Queen's Blizzard is a soft serve ice cream with customizable mix-ins. Wait, hold up. What the hell? A blizzard is a severe snowstorm that produces or has produced several inches of snow, along with very high sustained winds. In order for a snowstorm to be classified as a blizzard though, the snowstorm must have sustained winds of 35 miles per hour or greater, visibility less than a quarter mile due to the large amounts of snow or blowing snow, which is snow that has already fallen and is being blown around, and these conditions must last for more than 3 hours. If these conditions are met, then the snowstorm is classified as a blizzard. And no, not that blizzard. This combination of heavy snowfall and high winds makes for very dangerous conditions, especially for drivers, as not only is visibility reduced to mere tens of feet in front of you, but the roads essentially become an ice skating rink. According to the United States Department of Transportation, annually about 900 people are killed in vehicle crashes during snowfall or sleet. And according to the National Weather Service, 70% of winter-related deaths occur in vehicles. Severe thunderstorms are the big daddies of thunderstorms, and I do mean that literally. Typical rain showers and thunderstorms can reach 40 to 60,000 feet high, while many severe thunderstorms can reach higher than that, up to 75,000 feet high. I mean, okay, sure, they are taller than any old thunderstorm, but that's not what makes a severe thunderstorm severe per se. In order for a thunderstorm to be classified as severe, the storm must produce hail that is larger than 1 inch and produce winds excess of 58 miles per hour. You may think, that's pretty severe, but some severe storms have been reported as dropping softball-sized hail and producing winds exceeding 100 miles per hour. Not only will an umbrella not protect you from the softballs falling from the sky, but you should not even be outside in the first place if one of these is nearby. Jet streams are not twitch streams of jet airplanes. Instead, they are narrow bands of strong wind that primarily blow from west to east all across the globe. Like I discussed in the entry about wind, differences in air temperature will cause air to move and do some pretty cool things. Very simply put, this is basically the same thing, but on a large scale and high up in the atmosphere, about 4 to 8 miles in the tropopause. Usually jet streams move at about 110 miles per hour, but dramatic temperature differences can make these streams of wind move at 250 miles per hour or even more. The continental United States sits in the middle of 2 major jet streams, the polar and the subtropical stream. These can move around and change in intensity depending on the season, but during winter is when the jet streams are strongest due to the temperature gradients being more pronounced. You might just be sitting there right now and thinking, What makes these stupid streams of air so significant to me? Well, my friend, if you're in the United States, the jet streams play a significant role in how weather systems will move across the country. Ever wonder why generally most major storms that happen in the United States move from west to east? It's because of the jet stream. Also, the jet stream might be giving you a discount on cross-country flights from the west to the east coast, as jet aircraft will ride the jet stream to gain more speed without having to consume more fuel, like a surfer on a wave or that sea turtle from Finding Nemo. But there's one more thing though that jet streams can carry: incendiary weapon balloons. During World War II, the Japanese would take advantage of the jet streams to launch balloons with incendiary explosives across the Pacific Ocean and towards the United States. But these death balloons were largely ineffective, as only 6 civilians were killed in Oregon after discovering one of these balloons in a forest. If severe thunderstorms are the big daddies of thunderstorms, then supercell thunderstorms are the great granddaddies of thunderstorms. Supercell thunderstorms will often produce large hail, strong winds, and tornadoes, with the most violent tornadoes to ever occur to have come from a supercell. But what makes a supercell thunderstorm unique from all other types of thunderstorms is the internal structure of the storm itself. Supercell thunderstorms have what's called a mesocyclone, which is a rotating updraft in the core of the storm. Because of the mesocyclone, supercells are able to overcome the self-limiting mechanisms that will bring demise to regular thunderstorms, as well as surviving in environments that will usually kill regular storms, making supercells last for a very long time, up to several hours. While it isn't certainly clear exactly how a mesocyclone forms, we do know what 2 things will usually lead to one forming. We need wind shear and we need an updraft. The wind shear will create spinning tubes of air in the lower atmosphere, while the convective updraft of a thunderstorm will tilt these tubes of air vertically, causing the updraft to begin rotating as a vertical column. The formation of a mesocyclone is basically the start of the formation of a tornado, but not all mesocyclones will be able to produce tornadoes. According to the National Weather Service, less than 30% of mesocyclones that meet supercell criteria produce tornadoes. Even though not all mesocyclones produce a tornado, if rotation is detected in a thunderstorm, you're put into the red box of doom, because it's better to be safe than sorry. Downbursts are powerful winds that descend from a thunderstorm and spread out quickly once they hit the ground. I like to think of this as a thunderstorm letting out a huge, exhaustive breath. A breath so powerful that the winds during a downburst can reach as high as 110 miles per hour. Winds this high can cause EF1 tornado level damage. Now how the heck does one of these even happen? A downburst happens when a thunderstorm finally releases all the rain and hail it had been holding up so high for so long. As the precipitation falls, it will drag a lot of air with it too, gaining speed as it falls ever so gracefully towards the earth. If the relative humidity is low, your day is going to get much worse, as the dry air will allow the precipitation to cool the air as it evaporates, making the air itself heavier. As you all know, the heavier something is, the faster it will fall. As the cool, falling air reaches the ground, also known as a downdraft, it will spread out rapidly, and you have a downburst. You've probably heard a downburst referred to as a microburst, which basically means a downburst damages are confined to an area less than 2.5 miles across. If you see this image and say to yourself, "Oh look, tornadoes over water," you've just described what a waterspout is. Waterspouts are broken up into 2 different categories: tornadic waterspouts and fair weather waterspouts. Tornadic waterspouts are simply just tornadoes that got a little thirsty. They have the same characteristics and form pretty much in the same way as a regular tornado. As land tornadoes often are, they are accompanied by their friends: high winds, large hail, and hot plasma beams. Now, fair weather waterspouts form in much different conditions and are generally far less dangerous. As the name should imply to you, these waterspouts will pop up during relatively fair days. Usually these types of waterspouts will form along dark, flat bases of a line of developing cumulus clouds, and they will always form from the ground to the cloud, and not the other way around. Look at these 2 pictures. Many regular folks would call both of these tornadoes. They are wrong. This one is a landspout. Landspouts are typically confused with regular supercell-borne tornadoes, but not only do they form differently, but if you look closely, they even look different. Landspouts form without the presence of a mesocyclone. Instead, all you need is surface winds and the updraft of a thunderstorm. I'm sure it's far more complicated than that, but it's nearly 12 a.m. and I want to sleep. Landspouts are not long-lasting weather events and are typically considered to be less dangerous than tornadoes, and the damage caused by landspouts is close to EF0, but sometimes the winds will reach upwards of 100 plus miles per hour. What if I told you there's a certain type of tornado that sort of breaks the rules? This type of tornado, called an anticyclonic tornado, spins clockwise instead of the counterclockwise like most normal tornadoes do. But seriously, these tornado types are extremely rare. Only 1% of the tornadoes that occur are anticyclonic. These rebellious columns of rotating air usually form as a satellite tornado of a parent tornado, or they can form in tropical cyclones or in mesovortices within bow echoes. A multiple vortex tornado is a tornado that contains several vortices called subvortices rotating around a parent vortex or circulation. Although they look pretty small, they can still pack a pretty hefty punch. It has been measured that these little vortexes can add 100 miles per hour to the ground relative wind speed within the main tornadic circulation. Okay, so say for instance your tornado has wind speeds of 100 miles per hour. That's within the main tornadic circulation. Now add the 100 plus mile per hour wind speeds of one of the subvortexes on top of the wind speed of the main circulation, and you get some pretty high wind speeds. On top of that, these subvortexes can move pretty quickly around the main circulation at more than 100 miles per hour. One notable multiple vortex tornado was the 2013 El Reno monster. This tornado was the largest tornado on record, being 2.6 miles wide and having maximum wind speeds of 302 miles per hour. These wind speeds were mostly confined to the subvortexes as they moved erratically around the main circulation. Black ice is a thin coat of highly transparent ice that forms on roadways during freezing or icing conditions. But why is it called black ice? You just said it's transparent. Well, the layer of ice that forms on the road is so thin that it looks almost invisible, pretty much taking on the color of the road. If the temperature rises above freezing during daytime, any snow or ice that was on the road will slowly melt and cause road surfaces to become wet. Later on, when the temperatures drop below freezing while the road is still wet, black ice will form due to the refreezing. Black ice also forms when moisture in the air condenses and forms fog, then the temperature drops below freezing. Have you ever wondered to yourself, why the hell are these signs on bridges? Well, it's because bridges and overpasses are prone to black ice formation. Why exactly? Because air is able to flow under the bridge, keeping the bridge nice and crispy cool. Lake effect snow is snow that is caused by the movement of cold air over warm waters. Lake effect snow is common in the Great Lakes region of the United States during late fall and winter. How does this happen exactly? Or why is this very prone in this area? As cold Canadian air moves across the warm, open waters of the Great Lakes, heat and moisture are transferred into the lowest portion of the atmosphere. As the warm, moist air rises, condenses, and freezes, narrow bands of heavy snowfall form, and I really do mean heavy. In 2014, Buffalo, New York would see one of the worst lake effect snowstorms in recent history, with an average of 5 feet of snow falling within a 48-hour period. There were 13 fatalities with this snowstorm, hundreds of roof collapses, structural failures, and isolated power outages. As someone who rarely experiences snow at all, it absolutely fascinates me that these little flakes of ice can cause so much destruction. Derechos are fast-moving bands of thunderstorms with destructive winds. As a storm grows in size, it forms what are known as bow echoes, or large curved packs of thunderstorms. These packs of thunderstorms curve because the downbursts are stronger in the center of the storm. The stronger the downburst in these storms, the more curve you get. Or are these called bow echoes? Because on radar, it looks like an archer's bow. It's that simple. The wind speeds caused by a derecho are usually 58 miles per hour, but they can be as high as a breezy 130 miles per hour. That's tornado level wind speeds, but unlike a tornado, the winds shoot straight. These winds are called straight line winds and are pretty damaging, and these winds do not occur within an isolated location. In order for a cluster of thunderstorms to be considered a derecho, the damaging winds must be at least 240 miles long. Oh, and the word derecho means straight in Spanish. If you're quaking in your boots because of how scary this sounds, don't worry. Unless you live here in the Midwestern United States. Derechos occur in the Midwest pretty often, and if you live here, you've probably been in one. According to NOAA, they occur about once every year. One of the worst derechos to ever occur happened in 2012 and caused about $1.2 billion in damages as it plowed its way through, pretty much the entire Midwest. And unfortunately, 22 people lost their lives in this derecho. A fire whirl is a spinning vortex column of ascending hot air and gases rising from a fire. You might think to yourself, that looks like a tornado but on fire. You're pretty close, but these fire whirls are more like dust devils that caught fire. The true fire tornadoes are further down this list and are, as I keep saying, pretty terrifying. Just like dust devils, fire whirls can range in size and intensity from being small at a few tens of feet tall to being absolute monsters at a few thousand feet tall. The core of one of these fire whirls can reach nearly 2,000 degrees Fahrenheit, which is hot enough to melt aluminum. In extreme cases, some fire whirls can have winds in excess of 120 miles per hour and last for 20 minutes. Essentially an EF2 tornado, but that somehow caught fire. Fire whirls usually form during active wildfires when hot, dry air caused by the infernos rises. As heat rises in small areas, it does so in columns. As more and more of the hot air rises, it will begin spinning. The spinning column of hot, dry air will begin to spin faster and faster as more air is drawn towards the center of the rotation, similar to how a figure skater brings their arms close to their body to spin faster. And boom, a fire whirl is born. Have you ever heard someone say, well, that was like a bolt from the blue, when something unexpected happens? This saying is based on a weather phenomenon called a bolt from the blue, which is a lightning strike that occurs when the skies appear to be clear and is usually very startling. These seemingly random bolts of lightning originate from the top of a storm cloud. The bolt will usually travel a large distance in clear air away from the storm cloud before it angles downward and towards the ground. These types of lightning strikes are usually negative in polarity and occur in pretty much the same way a regular lightning strike does. They just originate way higher in the storm cloud. But because the lightning bolt has to travel a great distance, the bolt has a lot more energy. These bolts can travel about 25 miles away from a thunderstorm, which is why it is advised you stay indoors even if you think a thunderstorm is too far to harm you. When you think of a monsoon, you think of constant rain and flooding waters, which is half true. A monsoon is a shift in winds that often causes either a very rainy season or a very dry season. In fact, the word monsoon comes from the Arabic word mawsum, which means season. During the spring/summer season, the land is heated up and the land becomes warmer than the ocean. This causes moist air from the ocean to blow onto the land, where it condenses and forms rainstorms. In the winter, it's basically just reversed. Monsoons usually happen in tropical and subtropical climates. A lot of the most well-known areas to have monsoons in the world are South Asian countries like India, Bangladesh, and Myanmar. These areas depend on the monsoon rains for agriculture as they do not have large irrigation systems to supply water year-round. Instead, they rely on the shallow aquifers and groundwater reserves which are filled by the monsoon rains. Monsoons also happen in the southwestern United States, often during the summer months, with the monsoon seasons being fueled by the warm, moist air from the Gulf of California and the Gulf of Mexico. These rains can be firefighters themselves, as the summer months in this region of the United States can be prime time for wildfires. So thank you guys for watching my Iceberg video. This is part 1 of a multi-video series on an iceberg I've been developing about weather. I've been working on this for like maybe a few months now, mainly due to the fact that I've been busy with school and doing projects for school. I haven't had time to really focus on this video project. I think this Iceberg series is going to be 3 video parts because there's a lot more material I'm going to cover. So if you guys want to help support me in making this Iceberg series, I recommend you just drop a like, subscribe. I'm thinking of starting a Patreon, so you guys, if you want to support me that way. I already have a buy me a coffee, if you guys know what that is. Just donate me $5. You don't have to, but if you do, I will appreciate it.